All right, today we continued with systems of equations using elimination method, but a little bit more difficult. So let's take a look at a problem. Here you can see the system. Now, are there any equations that are there any variables where the coefficients are the same or opposite like we've had so far? No. And so what we got to do is we got to take a look at the least common multiples of the coefficient. So let's look at the x values. We got a 3 and a 9. Now, when you find the least common multiple, don't worry about the sign. Just look at the value. And so the least common multiple of 3 of 9 is 9. Let's look at the y values. The least common multiple is 35. Now, because the x already has a 9, we're going to keep that equation and we're going to manipulate and multiply and use the distributive property on the second equation to make that first coefficient into the opposite, which is a positive 9x, by multiplying both sides of our equation by -3. And so we're going to use the distributive property. Now, the second equation, the coefficient is -9, and so we multiplied once again the first equation by -3 to make it into positive x. And so when we distribute, we end up with 9x minus 21y equals 48. Now we can see that the x variable can be eliminated. And so then we continue on with our equation. We end up with -16y equals 64. And we divide both sides by -16. And we end up with the solution of y for equals -4. And now, just like we did before, we're going to go ahead and substitute the y value into one of the original equations. I'm going to go ahead and use the first equation. Now, because we solve for y, make sure you substitute for y, not for x. So let's go ahead and rewrite our equation. We end up with -3x plus 7 times -4 because y equals -4. Then we multiply, and we end up with -28. What do you do with the rest? You bring it down. We undo our constant. Now we end up with -3x equals 12, and then we divide both sides by -3 by undoing multiplying, and we end up with the solution of x equals -4, and we write our solution as an ordered pair. Since both x and y equals -4, you can place them wherever, but make sure you guys place it under the appropriate coordinate. Let's take a look at another equation. Here again, are there any of the x or variables where it is opposites like we had before? No. How about the same values where we can multiply by -1? No, the coefficients are not that way, so we need to take a look at the least common multiple. So let's look at the x equation. Sorry, the x variables. And you end up with the least common multiple of 16 for the coefficient of the x's without the signs. Let's take a look at the coefficients of the y. With 10 and 6, the least common multiple is 60. And so what I'm going to do is I'm going to go ahead and try to eliminate the x's because one of them is already 16. So I only have to multiply one of the equations by using the distributive property. And so let's go ahead and keep the first equation because it's already the least common multiple of the coefficient. And we're going to multiply both sides of our second equation by 2 because that's going to give us an x value of -16. That way we're able to eliminate. So I already went ahead and distributed, and now we can see that the x's can be eliminated. And then again, war and peace, you end up with -22y equals 22. Divide both sides by -22, and you end up with the solution of y equals -1. And I went ahead and wrote down my solution and made sure that I put the y value where the y coordinate goes for my ordered pair. I'm going to go ahead now, just like we did before. We're going to substitute our y value into one of the equations. I'm going to use the first one. And so since y equals -1, I'm going to substitute the -1 where we multiply by -10. And so instead of -10 times y, it's going to be -10 times -1. And then we follow the steps of solving equations. We're going to multiply -10 times -1. That gives us +10. We bring it down. And then we undo our constant. And then as you can see, we end up with 16x equals 0. Now, do not get scared when you see 0. 0 is a value. And so I'm going to continue. Divide both sides by 16. And we end up with the solution of x equals 0. and I'm going to place that in the coordinate. Now, again, you want to check your solutions, and in this video, I'm not checking our solutions, but I have the correct solutions on my piece of paper, and that is correct. But if you guys, when you guys, I should say, check your solutions, you guys will see that this is the correct solution. Let's take a look at another problem. Again, let's look at our coefficients for our x and y's, because none of the coefficients are the same or opposites like we had before. And the least common multiple of the x coefficients is 40. For the y, the least common multiple is 14. Now, as you can see in this case, none of our equations variable coefficients match the least common multiple. Because of that, we're going to have to multiply both equations by a value. I'm going to go ahead and use the y least common multiple, and so I'm going to multiply the first equation by positive 7, and that's going to give me negative 14y, a value for the y coefficient. I went ahead and distributed, and because we have a negative 14y, we want to make the y value positive 14y, and so we multiply both sides of the equation by 2, and that's going to give us negative 20x plus 14y equals negative 50. Now, because we use the distributive property, we multiply both sides of the equation. Now we can see that the y values can be eliminated. We eliminate it. Negative 28 minus 20x, it equals negative 48x because they're at peace. We divide both sides by negative 48, and we end up with a solution of negative 1 for x. Now we place that in the appropriate area, and now we're going to substitute the x value into one of the equations just like we did before. Because I solved for x, instead of negative 10 times x, it's going to be negative 10 times negative 1. And you use the distributive property. And we're negative 10 times negative 1 is positive 10. And then you guys know what to do from here. Undo our constant. We end up with 7y equals negative 35. Divide both sides by positive 7 to undo multiplication. And we end up with a solution of y equals negative 5. And then we place the negative 5 into the appropriate ordered pair solution. Now, again, you can check your solution, which you have to check your solution, I should say. And this is the correct solution. And let's do another very similar problem. Take a look at our x coefficients, our y coefficients. Again, none of them are like the original problems that we had. In this case, I'm going to use the x values. I'm going to eliminate the x's, okay? And so since I'm going to use 15 for the x's, I'm going to multiply both sides of the equation by 3. And that'll give me a positive 15x on the first equation. And you guys know how to distribute from there. And so because the first we distributed and we end up with positive 15x, we want the second one to be negative 15x. And that's why we multiply both sides of the equation by negative 5. And so as you can see, we distributed. Now we can eliminate the x's, and we end up with 57y equals 0. Now we need to undo multiplying by 57 by dividing both sides by 57, and so our y solution is 0. Place it in the appropriate coordinate for our solution, an ordered pair. And now we're going to take y equals 0, and we're going to substitute it into one of the equations, and I'm going to go ahead and use the first equation. So since we solved for y, we're going to substitute 0 for y. So instead of 4 times y, it's going to be 4 times 0. And then from here, we've been doing this for quite a while now. You go ahead and multiply, bring it down. 5x plus 0 is the same as 5x. And so you end up with 5x equals negative 30. Divide both sides by 5, and you end up with the solution of x equals negative 6. And so our final solution is negative 6, the ordered pair negative 6, 0. Now again, you would be checking your solution. I have the solutions on paper, and these are correct. And so these are the more difficult of all the problems that we're going to be doing. If you guys have any questions, you guys know to come see me in the morning or before school or after school or during lunch. I hope you guys were able to use this video for help.